In this demo, we'll learn about techniques we can use to produce strings representing other data types. We'll focus on ways to format datetime values into their string representations, including how to provide a format specifier which controls the format of the final string. A requirement for the summary sales report was to include each item's sales date as a row in the output. Our date property on the process data is a datetime offset instance. To include this in the report, we must format it as a string. Formatting is the process of converting the value of a type into a string representation. Classes and structs in .NET ultimately inherit base behavior from the object class, the type hierarchy root. The object class includes a virtual toString method that returns a string representing the current object. By default, calling toString returns the name of the type. Although it identifies the type, it fails to provide any information about the instance of the type. When defining a type, we may override the toString method to provide a more helpful string representation. In .NET, the toString method of each primitive value type has been overridden to display the object's value, which is more meaningful than its name. It's essential to consider culture when formatting types, such as numbers and dates. Different cultural rules may dictate how these values appear when formatted as a string. .NET provides mechanisms to control the output format and the culture applied when formatting some of its built-in types. We'll add a new line to include the date on the report. We'll continue to use operators to concatenate a label before the value. To begin formatting a datetime or datetime offset instance, we may call its toString method. The toString overload accepting 0 arguments will default to using the general format and the current culture. We may provide single character format specifiers as a shorthand way to request specific date format strings. For example, the lowercase d format specifier will format the string using the culture's short date pattern. Several single character format specifiers define standard formatting that may be applied to both datetime and datetime offset instances. It's important to note that some datetime string format specifiers that we'll use are case sensitive. Here are some other standard specifiers and an example of their output for the ENGB culture. An uppercase D specifies the long date pattern. An uppercase F specifies the long date and time pattern. A lowercase u can be used to specify a universal sortable datetime pattern. Culture does not apply to the universal sortable pattern, and it produces consistent results every time, making it well suited when storing data or passing dates to other services. Any date and time format string that contains more than one character is interpreted as a custom date and time format string. For example, we can use this format string to represent the date as a string starting with the long month name and day, followed by a comma, and their 4-digit year. Our report will use the long date format identified with the uppercase D format specifier. When dates are formatted, the date time format info from the current culture is used by default. When we pass an optional iFormat provider into the toString method, its datetime format info will be used instead. The datetime format info object represents required information about how dates should be formatted for a specific culture, including the order of the day, month, and year components. We'll ensure that our date is formatted according to the current application culture by passing in the configured culture info. With this line added, we can rerun the application to produce an updated report. Our report now includes the date as the first of the 3 rows relating to each sale. It has been formatted into the long date format as used in the UK.